Hello friends, today we are going to see principle of measurement of sensor and its working. In this part, we will see details about the principle on which the sensor is working and the various sensors with the details. So the today's topic is principle of various sensor and its working. In this slide, we will see the measurement working of the sensor and what is the principle behind it. So we'll start. See here, the principle of measurement of the sensor is at the site of glands. You will see here where mechanical, optical, electrical, acoustic, thermals and chemical and various field you will see here. Depending upon the various field, which characteristics or which parameters we require, that has to be sensed and has to be captured. That signal is very important. Now we'll start with the mechanical field. Obviously in mechanical field, various characteristics like velocity, acceleration, force, strain, movement torque, viscosity, stiffness, roughness and crispness is required. So to sense these particular parameters, we require certain sensors, and the sensor we will see in details later on. Now we'll see in optical field is also required various parameters. The parameters like wave, amplitude, phase, polarization, spectrum and wave velocity. In the same way, when we consider in the electrical field is also having some important parameters that has to be sensed by the sensor. Now what is that? That is charge, current, obviously the current sensor, potential difference. So the sensors also having a sensible capability to sense the potential difference also. Then electrical field, conductivity and permittivity. In the same way, radiation, biological field, magnetic field also having certain parameters, and that particular parameter that has to be sensed. Now we'll start one by one various sensors. We will start with one examples and the working. Now first parameters with light, and obviously light is connected with the optical phenomenon. Now the sensor which sense that optical phenomenon is obviously it is called as optical sensor. Now there are various types depending upon that working. So the first type of the optical sensor is through beam. Now let's see the figure how it's working. See here, these are the symbol of optical sensor, and here is the diagram where transmitter continuously transmit the signal to the receiver. So obviously the direction of the signal is only in one-way direction. Now here is the target scene is there. Means what? If this particular obstacle cut this particular signal, then what will happen? See here. Through the beam, if target is in between the transmitter and the receiver, obviously the distance between transmitter and receiver become low, and that capture by the transmitter by this sensor phenomenon, and this type of sensor is called through beam sensor, and this is optical sensor. Now the thing is that where it has to be used, that we'll see. This type of sensor is mostly in use in lift. So the transmitter and the receiver continuously send the signal from transmitter to the receiver as the obstacle, or you can say target, is coming. The distance between transmitter and receiver change, and that change distance is to be sensed by the transmitter itself, and this is called the through beam optical sensor. Now the next type of the optical sensor is the retroreflective sensor. Now in this type, this is the symbol of the optical sensor as same. Now in this type, transmitter working as receiver also, and that's why this side is called trans-receiver device. So transmitter as well as the receiver working in the same way. Now here is reflector is there, that is also called prismatic. Now when in retroreflective sensor the signal is transmitting and it's reflector back to the reflector, and it is also called a prismatic. Now when the signal transmitting and reflected back to the reflector, and also another frame when it is receiving at the same time, but when retroreflective sensor coming with an obstacle. Now when this obstacle coming in between that, the distance become change. So if the distance change from transmitter to the reflector and it become low, and that distance is changed by the transceiver system itself, and that sensed by the retroreflector, and this is called optical sensors. When another move to the type is called diffuse. So in diffuse type of optical sensor, the same symbol here we have seen. Now transmitting the signal as well as the receiving signal in the same way, but here is reflector is missing. But the target, when it is come in between that signal, then it transmit the signal, or you can say again reflect back the signals with that obstacle. But it may possible that the receiving signal may be changed through the target, and the many more possibilities to reflect back to the receiving side. So this type of diffuse sensor is not most of the use in domestic as well as industrial applications. Now we will move to another type of sensor where light sensor is to be used. So means what? In earlier slide, when we see the optical phenomenon is there, where the signal of a light is to be considered as a sense, but in light sensor we has to be sense of a light with atmospheric environment. So where there are various types and various principles to detect a light. For that there are various types. So here is one of the type of light sensor. So the thing is that what is the light sensor, how it is working, what is the principle behind it, what are the application. Now we will see one by one what is a light sensor. The simple thing is that a light sensor is something that robot can use to detect a current ambient light level. Means what? Most of the times a line follower robot used at ambient light level, how bright or how to dark. There are range of different type of light sensors. Means different range is decided depending upon the which type of light sensor we are using. So first is start with the photoresistor. One of the common topic, or you can say common used sensor, is LDR. Now we'll see photoresistor light sensor. What it is? It is a light dependent resistor. So obviously, as I'm saying, it is an LDR type of sensor. So how it is working? That is working with the slowly lose its resistance and expose to a high level ultraviolet light. As a result, it converts light energy into electrical energy. So thing is that when, depending upon the ambient light, whether it is low or whether it is high, so the brightness increases the resistance of a sensor, or the brightness decided which resistor has to be changed. Now, how it is working? This is called as the principle of a photoresistor, or you can say LDR. The thing is that when highly resistance semiconductor are sensitive to a high photonic frequency. So these are a special type of semiconductor which are sensitive to the photonic frequencies, and these photonic frequencies which are nothing but light particles, and light particles are photons. So when it is contact with the semiconductor, they cause electrons that were bound to metal and jump to another piece of semiconductor. Means what? When it is contact with another semiconductor, the electrons jump from one semiconductor field to the another semiconductor, and that jump of electrons means moving of electrons hit the semiconductors and electron knock loose. This creates very effective conductive flow of electricity, and that only travel through the semiconductor when it is the presence of light. So jump of electrons from one semiconductor to the another semiconductor is only and only happen when the presence of light is there. And why it is happened? Because it is high photonic frequency, means it is very sensitive to the light. Now this is the picture of LDR, that is the light dependent resistance, or you can say photonic resistors. Now, what is the application of this LDR? The photoresistors are used widely in various purposes. So what are that? It requires a light to determine whether a device should be on, off, or set to a particular position. So when we have to decide whether devices should be on, off, or set to a particular position, this photoresistor are used. So it is responsible for turning street light, whether it is on or whether it is off, or measuring amount of light that become camera pickup. So in most of the cameras, whether it is digital cameras, whether it is a mobile camera, to sense a particular ambient of the light, this particular light sensor is to be used, and also it is used for the street light, whether it should be on or whether it should be off. So most of the types it is also used for alarm clock also. So in advanced type of alarm clock, it's also used to sense the light, and depending upon the sense of light, it's working. Now photoresistor is also used in the dynamic compressor to control gain reduction, and that can be calibrated to respond infrared light. So this is an industrial application. In industrial application, for the response of infrared light, and a calibration to control a gain reduction is used. Now, we will move to photodiode light sensor. Now the thing is that how it will be used, and next is what is the principle behind it. The photodiode sensor is a system accessory for the lighting control system. It allows control of lighting level based on the how much natural light is present. So depending upon a natural light, not an artificial light, the sensitivity of the photolight sensor is working. Now, how it is working? So the principle of light sensor is here with, see here, a photon sufficient energy strike the diode and it creates an inner photoelectric effect. So the another phenomenon is happen here, the photoelectric effect. If absorption occurs in the junction depletion region or one of the diffusion length away from it, these carriers are swept from the junction by the built-in electric field. So here is two junction is there, one is depletion region, another is diffusion region. So when it is absorbed the light by one region and it is moved to the another region, it inbuilt an electric field of the depletion region, and thus holes or electrons are moved from anode to the cathodes and hence photocurrent is produced. So when electric field occurs from anode to cathodes and the electrons move from anode to cathodes, it makes and photocurrent is produced. The total current through the diode is the sum of dark current, that is nothing but generated in the absence of light, and the photocurrent. So the dark current must be minimized to maximize the sensitivity of the devices. So the ambient light, or you can say a natural light, makes a main phenomenon, or you can say major role in these devices for the maximize the sensitivity of the devices. Now, what are the applications of this photosensor? It may be used to respond to incident light or to the source of light, which is the part of same circuit or the system. A photodiode is often combined into a single component with an emitter of light. Usually it is an LED. However, it being used at major scale in homes and automatic lighting in vehicle as well as the same purpose in room also. Now, here is the actual picture of a photolight sensor where the sensor is in their area and here is our power lightning. Now, the another type of light sensor is phototransistor. So in this type of sensor, the transistor is used, and in earlier light sensor, the diode is used. So in phototransistor sensor uses a level of light it detects to determine how much current can pass through the circuit. So if the sensor is in the dark room, lets a small amount of current through, and if detect a bright light, then a larger amount of current through the devices. So the simple thing is that when a small amount of light is present, a low current is passing through the transistor, and when large amount of light is present through the atmosphere around the sensor, then large amount of current flowing through the devices, and the device name is transistor, and that's why this sensor is called phototransistor light sensor. Now the principle or how it is working. So a phototransistor is an electronic switching and current amplification component which rely on exposure of light. It is the main line is here. So it is depending upon the exposure of light to operate. When light falls on the junction, reverse current is flowing through the devices which is proportional to the luminance of a light. In the same way, a phototransistor are used extensively to detect light pulse and convert them into digital electrical signal, and these signals operated by light rather than electrical current. So electrical current makes a major role to devices should be on, or you can say switching purposes, and digital electrical signal converted from the light pulse which is detected by this phototransistor. Now it is capable of converting light energy into electrical energy. As you can see in the principle, it is in devices which converted ambient light, or you can say natural light, converted into electrical energy, and the phototransistor work in the similar way as working as a photoresistor, which is popularly known as LDR, that is light dependent resistor, but it's able to produce both current as well as the voltage, while photoresistors only capable of production current due to this change in the resistance. So you can easily consider the difference between photoresistors and the phototransistors. So in phototransistor, whatever the electrical signal is detected, it can be a voltage or can be current, and in photoresistor the detected electrical signal is only and only current. Now in phototransistor, the transistor with the base of terminal exposed, instead of sending current into the base, the photons from the striking light activate the transistor. Now here is how a look like a phototransistor. See here, it almost look like LED, it's almost look like LDR, but it is a phototransistor sensor where our electrical signal sends not only voltage but also a current signal. Now, so the various application of a phototransistor is punch card reader, security systems, encoder where measured mainly speed and direction, electrical control, computer logic circuitry, relays, lightning control, level indications in counting systems. So in this various application, our phototransistor is used. In earlier slide, we have seen about the different type of photosensor. We have seen also different type of optical sensor. Now it's time to see the another type of sensor, that is sound sensor. So how a sound sensor look alike? See, this is a sound sensor where it is connected to another devices, or you can say power source. Here is there, and here is our sensing area. To measure the calibration or to change the range of sound sensor, here is the area where we can change the calibration of a sound sensor. Now, what the sound sensor it is? It is actually, or you can say it's actually a microphone. a dynamically use induction coil position in the magnetic field of a permanent magnet attached to the diaphragm. Before moving a light sensor, we have to know what are the different active sensor, passive sensor, or you can say static sensor or dynamic sensor. This sound sensor is a type of dynamic sensor where the measurement of the signal is changed with respect to time is dynamically. Means what? It is fast, or you can say abruptly sense with the signal, and hence it is called a dynamic type of sensors. So again, the induction coil position in the magnetic field of a permanent magnet, and this permanent magnet is attached to the diaphragm. When a sound makes a particular signal, diaphragm is vibrate, and that vibrate signals attached to the particular coil which moves in the magnetic field, and that is produce the current. So obviously the output of a sound sensor is a current, not a voltage. So how it is working? When you make a sound, diaphragm is vibrate, and thus the attached coil moves in the magnetic field, which making or producing the current, and the current is output. Now, the depending upon the magnetic field produced by the diaphragm, and depending upon that which type of current, or you can say how much current produced by the magnetic field, is the type of sensor is there, that is called dynamic microphone, condenser microphone, ribbon microphone, and the carbon microphone. Now, how it's working is the main thing. So here is the principle of sound sensor, how it is working. Most of the microphone today use electromagnetic induction, and that is nothing but used in dynamic microphones. That is a real-time phenomenon. A capacitance change condenser microphone, or you can say piezoelectricity, a piezoelectric microphone to produce electrical signals from the air pressure variants. Microphones typically need to be connected to a preamplifier before the signal can be amplified with audio power amplifier. Means what? When we have to produce an electrical signals from the magnetic field, before that whatever the signal is captured from the magnetic field is to be amplified, and after the amplification the electrical signal and output is coming. Now here is look like of a microphone, and everywhere it is used, normally in office, homes, and from outdoor to indoor. Now it's time to see for the temperature sensor. Temperature sensor is a look-alike as you seen here. So what is a temperature sensor? Temperature sensor are a device used to measure temperature. It is difficult, however, to directly measure the energy of a molecule movement. So the temperature sensor are generally designed to measure the property which changes the response of a temperature with the type of temperature sensor. Means what? The rate of change of temperature with the earlier one and to set one, that is sensed by the temperature sensor. So depending upon the application of a temperature sensor which has to be used, so these are the types: electrical temperature sensors and mechanical temperature sensor. So Electrical temperature sensor type is thermistor, thermocouple, resistance, silicon band gap. In the same way, mechanical temperature sensor is thermometer and bimetallic strip. So, mechanical temperature sensor are used for the mechanical purposes and the electrical temperature sensor are used to sense the electrical signal. Now, we will see one by one. We'll start with the mechanical temperature sensor. In mechanical temperature sensor, thermometer is most of the common sensor. So, what it is? Thermometer. A thermometer is a device that measures temperature or the temperature gradient, means what? The variety of different principles. The principles of a thermometer is of included thermal expansion of a solid or the liquid with respect to temperature. The rate of change of pressure of a gas on heating or cooling, or you can sense the thermal expansion of a solid or the liquid with respect to temperature, and that has to be sensed by the thermometer. Radiation type of a thermometer measure infrared energy emitted by an object, allowing measurement of temperature with out of contact. Now, in liquid in glass thermometer specifically use a liquid, most of the times it's a mercury or alcohol, to measure the change in temperature. By the application of thermal expansion, as the particles gain heat on higher temperature and hence volume is rises and enabling us to read increasing the scale. As the temperature increases, as the gas or the heating purpose is increases, that is to be sensed by the thermometer, and hence is a way of working thermometer. Now, where the thermometer is used? It's widely used in industry to control regulated process, in the study of weather, medicine and scientific research. Here is the look of thermometer. Now, another type of temperature sensor is a bimetallic strip. Now, what is bimetallic strip? Bimetallic strip is consist of two different metal welding together, which are used to convert temperature changes in a mechanical displacement. So it is basically used when two metals are welding together and the rate of changing of the temperature with respect to time, that is sensed by bimetallic strip. Take a look of a picture of a simple bimetallic strip. Here is a look of a bimetallic strip. Now it's time to see the principle of bimetallic strip. It consists of two strips of a different metal which expand at a different rate as they are heated together. Means what? If one metal are welded together with another metal, the rate of expansion of a temperature with another is different. So the different rate they are heated, and usually it is used the steel metal with the copper metal, and in some case steel with brass. The strips are joined together throughout their length by brazing or welding. So bimetallic strips are welding when steel, copper or steel or brass metal are combined together. Now, the different expansion force that flat strip to beyond one way if heated, and in the opposition direction if cooled below its initial temperature. So as the temperature increases, the metal temperature increases, it's sensed by the bimetallic strip, and how it will be cooled down with the rate of time, it sensed by this bimetallic strip. The metal with the higher coefficient of thermal expansion is an outer side of the curve when strip is heated on inner side when it is cooled. See, there are a metal where outer side is another type of metal and inner side is another type of metal. So in this particular situation, which metal is rate of change of temperature is increases with respect to time with the another metal, and this phenomenon is sensed by biometallic strip. Now, what are the application of biometallic strip? It is basically used in clock. They are used in the clock to measure the temperature change when it lead to error of timekeeping. So there are a clock where automatically time is being calculated, and that is a major role of a temperature changes. Now in electrical device, bimetal strip used in a circuit breaker protect circuits from the excess of current. You can say an easy example in our household where a diffusion of a fuse is happened. A coil of a wire, how it is be used? There, a coil of a wire is used to heat bimetal strip, which bend and operates linkage, and that unlatch a spring operated contacts. A spring operated contacts is continuously contact from one side to another side. As the excess of current flows through it, the temperature increases, and that's sensed by bimetallic strips, and the contact has to be cut. This interrupt circuit can be reset and when the bimetal strip has been cooled down. So our fuse can be reused when once it is off light, or you can say our current household keeps off. But as a bimetallic strip makes a down to its temperature, it again use of a fuse which is in electrical devices. Now it's also used in fire alarm and as a thermostat. So it operated on high temperature. So when an optimum temperature has been obtained, bimetallic strip expands and switch off the thermostat valve. Similarly, in summer fire alarm, it expands to complete circuit and start off fire alarm. Other than this, bimetal strip are also used in time relay, lamp flashers, fluorescent light starters. In some devices, the current running directly through the bimetal strip is sufficient to heat and operate contact directly. So in fire alarms, it can be operated directly, it can be operated through the fluorescent lamp, it can be operated through the lamp flashers. So it is also a thermostat. Now it's time for the electrical temperature sensors. Mechanical temperature sensor we already know, that is bimetal strips and various examples. Now it's a time for electrical temperature sensor. So one of the topmost example is thermometer. So thermometer is a temperature sensing element composed of semiconductor material which exhibit a large change in the resistance proportional to the small change in the temperature. thermistor usually have a negative temperature coefficient, which means the resistance of the thermistor decreases as the temperature increases. So the resistance inside these devices is correlated with the temperature, but it is inversely proportional. So as the temperature of the ambient environment is to be changed with rate of increasing, then the resistance of a devices is decreases. That means the resistance of a device is inversely proportional to the increasing temperature. Now, how is the working of thermistor? Here is the principle of thermistor. That is, as the temperature sensor and it is placed in a body whose temperature is also has to be measured, it is also connected in the electrical circuit. When the temperature of a body changes, the resistance of a thermistor is also changed, which is indicated by the circuit directly as the temperature sense resistance is calibrated against the temperature. The thermistor can be used for some control which is depending on the temperature. Mainly, it is used for the calculation of thermistor are done using sophisticated formula. So what is that? Here is the application of a thermistor. There are many applications of a thermistor. So the temperature sensing, most of the obvious application of a thermistor is to be measure the temperature. They are used to do with a wide range of the product such as thermostat. In a rush current limiting, in the application, in this type of application of a thermistor, use initially oppose the flow of current by having high resistance into the circuit. Then the thermistor warms up due to the flow of electricity through the devices, and through this electricity the energy converted from electrical signal into the temperature signals, and it resistance dropleting current flow more easily. Now, in circuit protection, in this application, thermistor is used to protect a high limiting current by the amount of current that can flow into it, and too much current start flowing into a current through the thermistor. This causes thermistor to warm up and turn increasing the resistance of a thermistor, reducing the current that can flow through the current. Here is the look like of a thermistor. Now here we can see another sensor. The sensor name is thermocouple. It obviously a temperature sensor. A thermocouple is a temperature measuring devices consisting of two different metallic conductors that can contact each other and one more spot. It produces voltage when the temperature of one of the spot different from referring temperature of another part of the circuit. Means what? In a circuit, one part of the circuit having the different temperature, in another part of the circuits having the different temperature. To sense both the area and the rate of change of the voltage with respect to that the temperature has detected by this thermocouple. Now, the principle of thermocouple is detected in 1821 by a German Estonian physicist named as Thomas John C. Beck. It discovered when any conductor is subjected to thermal gradient, it will generate a voltage, and this is now known as thermoelectric effect, or it is also called as Seebeck effect. Basically, we connect two identical conductor which having a different temperature. Means what? we having different type of conductor which also having their temperature, different temperature. An electromotive force, that is EMF, producing and constantly produces minimal amount of voltage. Depending on the difference in the temperature, and hence the thermocouple can then attach to a multimeter and to measure the temperature. Thermocouple are self-powered and not require an external energy to operate it, and the main limitations of thermocouple is accuracy, as a system occurs less than 1 degree Celsius, and that can be different to achieve. So in the thermocouple, electromotive force are used with the different temperatures, and it is a self-power devices which not required an external power supply. Here is the application of thermocouple where the limited temperature has to be used. Is that you can see a thermocouple photos. Now here is the another examples of temperature sensor by the resistance increases. Up till now, whatever temperature sensor we have considered it is related with the change in the temperature, and the output of that particular sensor is either voltage or either current. Now here is resistance temperature sensor where it is similar to the thermocouple. It is also called as RTD, that is the resistance temperature detector, where it measures the temperature using the principle that is the change in the resistance. The rate of change of the resistance in the devices is sensed on depending upon the temperature change. This is basically used in the metal change. So in a practice, electrical current is transmitted through a piece of metal located in proximity to the area where the temperature is to be measured. They are slowly replacing the use of thermocouple in many industrial applications due to the high accuracy and repeatability. When an external current applied to the metal where temperature has to be measured, then RTD is mainly used. And this is due why we are using, because for higher accuracy and repeatability. So what is repeatability? Means what? As the change in the condition of the ambient light, ambient temperature or environmental condition, the output should not be changed. It should be repeated as the change in the input. That is called as repeatability. Now, how the working of RTD? It's a basically correlation between metal and the temperature. Now what is that? It is the relation between metal and the temperature. In earlier sensor we are seen about the relation between the temperature of the voltage or the relation between the current and the temperature. Now as the temperature of metal increases, the metal resistance of the flow increases. So the temperature of a metal and the resistance flow of electricity is directly proportional to each other. Similarly, as the temperature of RTD resistance element is increases, the electrical resistance is also increases, and the electrical resistance of RTD are measured in ohm. RTD elements are commonly specified according to the resistance in ohm at 0 degree Celsius. At 0 degrees Celsius, whatever the resistance is there is specified according to that. So most of the RTD specification with the 100 ohm. That means what? For the 0 degrees Celsius, the RTD resistance is 100 ohm and it should be demonstrated of 100 ohm only. The platinum is most commonly used metal for the RTD elements. So for the 0 degree, platinum should be shown as 100 ohm as output. So in RTD, that is the resistance temperature detector is also depend only and only the temperature, and as the rate of temperature increases, the resistivity or the resistance of this particular metal is also increases, and the output of the RTD is nothing but resistance. Now, what are the application of RTD? It is used in temperature measurement obviously, but it is replacing the thermocouple. Here is the photo of RTD. Now, another sensor to sense the temperature by using silicon band gap, and it is silicon band gap temperature sensor. So what it is? It is a sensor is an extremely common form of a temperature sensor, that is a thermometer, and it is used in electronic component. Its main advantage it is included silicon integrated circuit with very low cost. Now, how it is working? It is working is that the forward voltage of a silicon diode, which may be base emitter junction of a BJT, that is the bipolar junction transistor, and as it is depending upon the temperature and electronic circuit, therefore used to calculate the temperature of a diode. So when the forward voltage of a silicon diode which is present in the transistor, base emitter junction of a transistor is depending upon the temperature dependent, and as an electrical circuit used to calculate the temperature of a diode, the result remains valid up to 200 degrees Celsius to 250 degrees Celsius only, and when a leakage current becomes large enough to corrupt the measurement above this temperature, material remains such as silicon carbide, or instead of silicon it is used. So most of the times the transistor is used, and the transistor is material of silicon carbide which is used instead of silicon, and as the forward voltage of a sensor is increases and it become to sense the temperature dependent. Now, voltage difference between two PN junction, and you know all the well, that is the our BJT is made up of two PN junction. It is operated at the different current densities. It is proportional to the absolute temperature, and that is called PTAT. Now, the application of silicon band gap sensor is other than the measuring temperature. Here is the look like of silicon band gap sensor. Now, pressure sensor usually acts as a transducer. It generates a signal as a function of a pressure imposed for the purpose of articles, such as signal is electrical. The pressure sensors are used to control and monitoring in thousands of everyday applications. Like a pressure sensor can also use to indirectly measure other variables such as fluid, gas, speed, water level, and altitude. The pressure sensor used to indirectly measure other variables such as fluid, gas, water level and altitude. Pressure sensors are used also in various range of a diverse application in industry such as medical, aerospace, transportation system or in general industry for the test of measurement. Now, depending upon the application where a pressure sensor is used, it is divided in various types. So, absolute pressure sensor, it measures pressure relativity with the perfect vacuum. Gauge pressure sensor, it measures the pressure relativity with the atmospheric pressure. In the same way, vacuum pressure sensor, now in gauge pressure sensor measure the pressure relativity to the atmospheric pressure. Vacuum pressure sensor is used to measure a pressure less than 0 psi. 0 psi is per square inch. Differential pressure sensor is used to measure the difference between two pressure points. So most of the times in industry, two pressure point is available or more than two pressure point is also there. To measure that particular points, differential pressure sensor is used. Seal pressure sensor measure the pressure relative to the some fixed pressure. Now, how use a pressure sensor? The computer device and the smartphone that have touch screen display come with a pressure sensor. So that is used to be known. Whenever a slight pressure is applied to the touch screen through the finger, or you can say stylus, the sensor determines where it has been applied and accordingly to generate an electrical signal that inform the processor. So there are various type of touch screen is available. You can say capacitive touch screen, you can say resistive type of screen, but the sensing phenomenon of that particular screen is pressure type. So whenever a slightly pressure, it can be through the finger or it can be through the stylus pen, that determine and according to that particular sensors, it sends an electrical signals which is applied to the processor. As you see, in many types of sensors that determines the applied generators through the electrical signals that is used in the computer devices or any gadgets. In the same way, in automotive industry, pressure sensors is also used. So where it is used? It is in use in integral part of an engine, and that is used for the safety purposes. So what is that? In the engine, these sensors monitor the oil and the coolant pressure and regulate the power that the engine should deliver to achieve suitable speed. In instruments like digital blood pressure monitor and ventilators, pressure sensors are needed to optimize them according to the patient health and requirements. So many times, many of the hospitals, like in ICU rooms, use these ventilators, pressure sensors, which is optimized according to the patient health. So the range and the calibration of this particular pressure sensor is wide. Now the pressure sensors are now used monitoring gases and their partial pressure in industrial units so that the large chemical reaction takes place precisely control environmental condition. In airplane, the sensors are needed to maintain a balance between atmospheric pressure and the controlling systems. Hence, aeroplanes, the pressure sensor makes a vital role. Up till now, we will see various pressure sensors and their principles. Now, the technology behind the pressure sensors is one is piezoelectric. So, piezoelectric is one of the pressure sensors. Now, what is the technology behind it? Here is a piezoelectric effect. It is the electrical charge that accumulates in certain solid materials in response to applied mechanical stress in certain materials such as quartz to measure strain due to the pressure. In piezoelectric effect technologies, where electrical charge that accumulates in certain solid materials in response to applied mechanical stress. See here, in piezoelectric effect, here is the force applied. In orange side, you can see here this is the impact cap, and how the force is applied through these force sensors. Now, preload studs is also present, and housing amplifier is also there. So, when the pressure is applied through this direction as a force, it's converted whatever the pressure sensed by this preload studs, and whole housing converted into in electrical signals, and it is amplified through the amplifier. The quartz elements and the charge collection plate is also there to sense the pressure area and the pressure force. Now, the advantage of piezoelectric that generate a voltage proportional to the velocity crystal is deformed, so require no local power source. So it is not required an external power source because its velocity crystals deform. What is the disadvantage of that? They are highly impedance and that can peak stray voltage in the connectivity wires. The crystal is also prone to the cracking if overstrays happen. Now, the strain gauge technology. In strain gauge is an example of passive transducer that convert mechanical displacement into the change in resistance. In earlier slide, whatever the pressure is happened to the force, that is converted into electrical signal, and here's whatever the displacement it is happened, it is changed into the resistance. As you know very well, the type of displacement, it can be a linear displacement or can be an angular displacement. So depending upon the type of displacement, it is changed into the resistance. So the type is mechanical, electrical, semiconductor, or the photoelectric. So see here is a strain gauge indicator where strain gauge is present, and depending upon the type, whether it is mechanical, electric, semiconductor or photoelectric, it can be changes into the resistance. Now, advantage is no moving part and the small, and it is expensive. It is not an expensive. So the disadvantage is also present. It can be non-linear or it is needed to be calibrated in every time. So it is low cost, not a moving part. So maintenance is very low, but it is a non-linearity present is there, and calibration needed to be in every particular usage. Now, application is used for the residual stress, vibration measurement, torque measurement, strain measurement, compression and tension measurement. Now, another technologies used to sense is capacitive. It uses a diaphragm, means a rate of change in the displacement of a diaphragm that is calculated also in pressure cavity to create a variable capacity to detect strain due to the applied pressure. So when applied pressure is applicable to particular capacitors, it uses with diaphragm. The advantage of capacitor type of diaphragm is reduce interference in the signal to our amplifier and therefore making our system cleaner. SQ cars use this typically, they can help with the dimming lights. The disadvantage, it reduces voltage slightly and interference with direct current flow, and as fast as they discharge, they are almost useless in the providing anything for long drawn at bass notes. Now, in electromagnetic technologies, it measures the displacement of diaphragm by means of change in inductance, LVDT, Hall effect, or eddy current principles. The advantage of this particular type of sensor is very highly sensitive to the atmospheric quantity, very good operating speed, very low power consumption, portability, and used in anywhere, where the wide temperature sensor is also one of the type. Now the disadvantage is designing is complicated rather than the mechanical system, and also cost is important factor. Up till now, whatever the sensor we have seen, like the temperature sensor, pressure sensors, or any other sensors, here is another variety of the sensor where it is basically used for the agriculture purposes, also in use industrial purposes. Now we'll start with one type of sensors, that is the moisture sensor. Moisture sensor is a look-like picture is here. Now moisture sensor is measure the water content of a soil. A soil moisture probe is made up of multiple soil moisture sensors. Measuring soil moisture is important in agriculture to help farmers manage their irrigation systems more efficiently. Not only a farmer is able to generally use water to grow crop, they are able to increase yield and quality of a crop by better management of a soil moisture during the critical plant growth stages. So in moisture sensor is basically used to detect the moisture of a water soil. And why it is required? Because the farmer able to generally use lesser water to grow a crop, and they are able to increase the yield of a soil and quality of a crop for better management of a soil during the critical plant growth stages. Now, how the working of this moisture sensor? The moisture sensor work when the series of discs in the sensor expand, they get wet, and certain size they flip or micro switches. This interrupt the current going from the controller to the valves, whereby the controller will tell the valves to start watering in the middle of the rainstorm. If the valve does not get the memes, they don't turn on. When the disc dries out in the sun and the wind, then the switch flip back and the valves will water when the controller tells them to start watering. So the sensors itself make a role of a controller as depending upon the moisture it senses. Means what? In the rainstorm period, most of the times the moisture of a soil is increases, that is sensed by the sensor, and the watering level required for the crop is been less. In the same way, for the dry area where the sun and the wind is more, switch flip back to the walls and the water level controller start watering by the tailstep. So the controlling part is played by this moisture sensor. Now the types of this moisture sensor is one of the basic types is the tensiometers. What is that? Water filled tubes that you insert into the soil to the depth of the plant root. At the bottom of the probe is a porous ceramic tip. This tip and at the top of the probe is an above grounded gauge. So two type of tip is present. One is at the end of the plant roots, another porous ceramic tip is present at the above ground gauge. So the water from the tubes leaves the porous cap and enter the soil around it. As the moisture inside the tube reaches equilibrium with the soil moisture outside the tube, and the moisture tension register on the gauge. When soil is dry, a plant must use greater suction to extract the available water from the soil, and the tension meter gauges reflect this soil water suction and higher reading dries the soil. So here is how the controller can be happen when the soil is dry, when the moisture is high, when the tube reaches to the equilibrium, and how the working is goes on. Now you can see in the pictures of these various gauge moisture sensor. So most of the times the sensor is present inside the ground, and the controller part is above the ground. Now gypsum block is another type of moisture sensor that measure the soil water tension. A gypsum block is also called an electrical resistance block, a porous block typically made of gypsum, and it is placed at the top of a soil and must be maintained firm contact within it. See here. Here is a gypsum block sensor. The block contains two embedded electrodes into which wire is inserted, and other ends of the wire penetrate the soil surface. See here again, penetrate to the soil surfaces. As water moves the block to maintain equilibrium with the soil, the electrodes measure the electrical resistance that water generates, and portable wattmeter convert the resistance reading to water tension value. So the resistance of a soil with respect to the moisture is calibrated to the gypsum block. Here is the picture of a gypsum block. Now the application of Moisture sensor. I have already said that the moisture sensor is basically used for the agriculture purposes. Irrigation of crops represent 90% of the water used worldwide. Monitoring soil moisture in the root zone of a crops will optimize the irrigations. The benefits of optimizing irrigation should be the soil moisture since includes increasing crop yields, saving water, protecting local water resources, saving energy cost, saving fertilizer cost, with the result increasing in the farm's portability. Now, here is another type of sensor, that is the pH sensor. Before that, we are already seen about the pressure sensor, moisture sensor, and here is the pH sensor. Is the one of the parameters required in the agriculture industry. So what is that? Here is our pH sensor. What is pH sensor? Is an electrical device used to measuring pH of a liquid through a special probes are sometimes used to measure pH of a semi-solid substance. Typically, pH meter consists of special measuring probe, a glass electrodes connected to an electronic meter that measures and display of the pH reading. The probe is a key of pH meter and it is a rod-like a structure usually made up of glass. At the bottom of probe there is a bulb, and bulb is a sensitive part to sense a probe that contains a sensor. Now, pH meter range from simple to inexpensive pen like a device to measure a complex and inexpensive laboratory instruments. With the computer interface and several inputs for the indicators, temperature measurements to enter to adjust for slight variation in pH caused by the temperature. Specially meters and the probes are available to use special applications like harsh environment. There are also holographic pH sensor which allow the measurement of pH calorimetry. Now let's see various examples of a pH sensors. Litmus paper, phenolphthalein, methyl orange is an examples of a pH sensors. Application of pH sensor is cheese making we are using, where all cheese must fall within the fairly narrow pH range in order to ripen normally and develop flavor and textures. So there are various type of cheese, and depending upon their ripen normality, a pH sensor making an important role. Pool maintenance, the pH level is essential part of the swimming pool. Take care of the effect of comfortable water in the swim as well as chlorine availability. To sanitize your water, measure soil pH for happier and healthier plants. So pH makes an important role for the health of crops, where a pH soil is too acid makes as a low pH, or in alkaline with the higher pH. Nutrients present in the soil become locked up, and as a result correcting the pH has the same effect as applying to the fertilizer, since we have to unlock the plant's nutrients already it is present. So the plant's nutrients is used to unlock the presenter of measured soil pH. which is required for healthier and happier plants. Now, strain removal and pH level. Knowing the pH level of a strain is a key step in identifying the best method to removing it. A flat surface pH meter lets you read pH level of a fabric and carpet easily. So the pH level of a chemical which are used in the fabric industry also used for the strain removal. So here are the various use of the pH level, and here we ended our topic where we are seeing the various type of sensors, their working, their applications, their measurement level, their calibration, and here we ended the sensing elements with their measurement techniques. Thank you.